again, running that. There we go, yeah, so 10,000 by 21,999 factorial is 10,000. I did it that quick. Okay, what were some of my other things here? Let's go back here. Just want to make sure I didn't miss anything on the slides. Rule data, we saw that, classes, method, syntax. Control structures, yeah. No, not that. Oh yeah, sets. Okay, we had between and, so let's see if that comes out. 10 between 5 and, now see it still says between colons broken, but now notice, see it went back and said, oh, between and works though, so that's fine with that. 20, true, so true prints as true, which is nice. Between 5 and 6, false. You want to see the debugger? Between 5 and hello. Ah, okay, this is what happens when you break something. We actually get a debugger here. This is the mini display. Gives us choices. First off, it tries to explain what went wrong. A digit between 0 and 9 expected. So actually it was trying to convert this into a number. Didn't do very good at it. It was looking at the letter H. It's not very good. Now, I could say abandon if I know, oh yeah, I know what I did. I shouldn't have been the word hello. I can say proceed, and then it just returns self from that expression and tries to continue on. Who knows how well that's going to work. Oh, no, right, yeah, see, couldn't go any further, right? Or I can also hit debug. And debug brings up the wonderful little debug interface. So what we have here is the full online debugger. Now I'm still in the middle of running that expression. Okay, so let's go here, make it bigger. We have at this top level, we actually have a backtrace. So we can see that the most recent message sent was this. And as soon as I clicked on that, we have the source code available for that message, all right in the middle there. We also have the highlight of the actual thing we're trying to execute at the moment. And I can drill down in here. Now, I didn't write any of that code, so it's probably not my problem there. Those probably all work. Let's keep going further down. Now, also you'll see, here's the source code in the middle here. Down on the left-hand side, we actually have, we know that we're sending adapt to integer and send, and it's this byte string object over here. Now, just by clicking on this lower left-hand side, we can access the object and all of its instance variables. So let's click self. Oh, that's the hello. So this message is actually being sent to the word hello. Okay, and over here we have all of the, we have the magic this context, which is the same name as this thing up here. We have the top of stack, we have all the temporary variables, receiver and selector. You can also individually look at receiver and selector. Now, the fun part about this is I'm not just staring at it. Everything you see here is live. I can execute code against all of these objects, against everything that's here. I can even go back down and figure out where the mistake was. Okay, it was between and. We had just trying to go between 5 and hello. But really the problem was all the way back at the beginning. Watch this. I fixed the code here. Okay, so that's the code. It really should have been there right now. I hit save. Now, every time you make a change in the image, it wants to know your initials, because if you then export a package, your initials will go with it, and we just keep track of people's initials. There's a place to register your initials on SweetMap, so my initials from there. Now, notice that when I saved it, the rest of the stack disappeared. I don't know if you can see the scroll bar here. The rest of the stack disappeared, but I'm still in the middle of the calculation. I'm still now at the level where this code is about to be run. So I hit proceed. Now, even though the source code didn't change in the workspace, it ran it with 5 and 10. It ran it with a new code. Now, if I was actually looking at a real method that was actually part of the system, I would have ended up changing that source code and kept it with my distribution. So the whole idea of the Smalltalk debugger is it's always live. Everything you're seeing there is live. You can make changes. You can send messages to different objects. You can scroll up and down, try to figure out what's going on. And it's a much better setup than even Perl, as far as I'm concerned. Perl, you can kind of get in the middle of something, but you can't really have access that easily to the source code. You can't maneuver things. You can't restart stuff from the middle of an execution. That's all possible in Smalltalk. Okay, make sure that I've done the sales pitch there. Now, let's keep going here. What else we got here? String, we saw those. Classes. Oh, set to the class. Okay, so set new gives us an empty set. That prints as a set like that. Set new, we can store it somewhere. We can say A is a set new. And now I don't really need the print it because I just need it to do that. So if we go back to this thing, you'll see that one of them is do it. Okay, so that actually just runs the code. A is now a local variable assigned to this workspace. And so I can go here now and just say A, print it, and it still has that empty set. I can also inspect it. And what that does is it opens up a little inspector like we saw in the lower left corner of that other area there. It was self as a set. There's really nothing. Now, these are instance variables inside set, but you really don't ever look inside a set like that. But if you have an object of your own type, it'll have whatever your X and Y or whatever you called your instance variables. Now, let's do A, add hello. Okay, which returns itself, but really we want to look at what A is now. A, I'll just print it. There's a set, it's got hello in it. A as array. Coerce it to an array, that prints a different way. A as, let's see, A as ordered collection. These are all types that are built in. Ordered collection of hello. A as ordered collection inspect. If I do the right letter though. One of these. B? No, not B. Alright. There we go. So again, here's the ordered collection. It has an array built in, first index, last index. Again, that's internal stuff, but again, here's that word hello. That's probably enough for right now. Let's go back to slides. Method syntax. Control structures. Alright, control structures. So we'll have true, if true, 47. Print. So it's going to be 47. Now, if it doesn't execute the block, the return value is nil, because nothing got executed there at all. So by default, it returns back nil. Let's do something with a loop. So let's go A is 10. Okay. B is 0. Okay. And A, let's see, A greater than 10, or A greater than 0, while true. B colon equals B plus A, period, A colon equals A. There's actually easier ways to do this, but I just want to show the loop. Nice one, okay? And then we'll do that, so Command D, and then we're going to look at B, that's 55. So we just added all the triangle numbers there. So again, very simple, with traditional calculations available as well. Okay, let's go to the bigger collection classes, those are more fun. So we saw control structures, cascades, fancier blocks, samples of blocks, and now I can actually go through this sequence. Okay, so we can assign this block here. Notice this takes a single parameter. Single parameter X, I'm showing in a second how to feed that in, but basically it's a lambda expression with a single parameter. And it's going to send that parameter times 2 plus 3. Now that's a long thing to type, add 3 to double up, but what we now have on that left side is a block. It's actually a block closure. But we can just copy it around like any other object, pass it into a routine or whatever. And then we call value colon on it and pass the parameter going in. Because there's one parameter here, there has to be one value colon. If we had two parameters, we would say value colon, value colon. If we had no parameters, we would just say value by itself. So there wouldn't be any parameters at all. And so B is going to take that value, and here's A takes the value 17 over 2. Well, I didn't show you the fractions are all exact as well. This is pretty nice. So if we take 100 divided by 44, it reduces it down to the lowest possible fraction. If I really wanted that as an actual floating point number, I'd have to convert it to as float. And now I have the actual value. So what's nice about that is that if we take 100 divided by 44 times 22, we get exactly 50. So it's doing the right calculations internally. Okay, so let's do that other function A. It takes a single parameter, and it's going to do x times 2 plus 3. And then we do it. Now, if we look at what A is, it's a closure. So in other words, a block closure defined in undefined object do it. Undefined object do it is sort of where it's behind the scenes name for working in a workspace. So, am I running out of time? Oh, you're doing this. I don't know what the.
I thought we were running out of time.
Oh, you don't know we're running out of time? Are we? No?
No, I just figured we could go through the example.
Okay, great. Let me just keep going through the little slides a little more then. Okay. So let's just do that. Anyway, like that. That's good. You saw that. The collection classes. There's a number of collection classes to be able to create structures. Ordered collection is just a series of objects. They don't have to be the same type. So it's whatever objects happen to be in there. An array as a fixed size or the collection. Set, we saw examples of those. We can add, and each time we add an object, there's only be one of each object in there, so it's a mathematical definition of a set. But if you want to have something that's similar to a set, but you want to count the items, so if you add it twice, you get the number 2 back, then you use a bag instead of a set. So it's like a set, but we have a small integer associated with each one of those. A sorted collection, we can take any one of these and turn them into a sorted collection, and it will sort it based on rules that we'll give. A dictionary is like a hash and Perl key value mappings. Interval, 5 to 100 by 3. That's stored internally as just 5, 100, and 3, so it only becomes explicit values when you actually use it. So it's a very small, easy to represent thing. Now, on everything that looks like a collection, and there's actually about half a dozen other collections as well, there's a number of common protocols that they all understand. Protocol means a suite of method calls that fit a similar set of operations. So collect is one of my favorite. It's like a map in Perl. So we would take, for example, 1 to 10, and one at a time, the values 1 through 10 are going to be dropped into :n in that block on the right, and then we're going to evaluate 1 over /n, so that would be 1 over 1, 1 over 2, 1 over 3, 1 over 4, and so on. And those will be exact fractions because I'm just using the normal /. So that would be a bunch of fractions. Do is just an iterator. So fractions, for each of the fractions that result from that, we're going to call 10 times HTML div each. That's actually some code from Seaside to create a div that contains just that fraction. Just going to use the print string from each of those. Select is like rep in Perl. It selects different things. So we take the fractions, and we're looking for all the fractions that are greater than 0.25. And we're going to get back some subset of those. Okay? Now, Squeeze Smalltalk works in the method of an image, which means that we have a collection, an already existing set of objects and the UI and all the classes defined and everything. And so in Smalltalk terminology, image means everything above the VM layer. The VM is the only part of it that's machine specific. So there, for example, will be a Windows VM or a Mac VM or a Linux VM. But what's nice is that everything above that is pretty much universal. You can pretty much just take it right across. The VM is really low level. It uses byte codes, and in fact, it actually is literally byte codes. There are only 200 of them, so they all fit within a single byte. And we can actually see, oops, spot here. If we, no, I won't do that yet. Back here. Okay, so this also includes all the core behaviors. It just simply is all the, it's also the thing talking to the operating system and so on. The VM also includes, or excuse me, the image also includes the development, the debug tools. There are technologies for loading your code into a minimal image so that you can deploy it with a minimum amount of space. But the entire image is only about 15 meg anyway. So as long as you're on any modern machine, you can have an image running and not worry about the fact that you've got all your development tools, your debugging tools, all already in the system. We do that all the time. We don't even bother stripping anything out of it. Now, typically, though, what you'll do is you'll work with an image that has your code in it until you want it to deploy, and then you extract it into a Monticello file. Monticello file, the name is meaningless. It's just the name of someplace in the US. The Monticello file contains all of your code and instructions about what it depends on. And so you can load a Monticello file in, and it will also pull in all the associated things that are related to it and so on. So typically what you'll do is you'll develop, you'll spit out a Monticello file, you put that into a repo somewhere, and then you go to your production image, and you'll pull in the Monticello file, and anything that needs to get updated will get updated, and then you're running your new code. And there are minimal images to remove the needed stuff. So we've already seen the workspace. Now I'm going to show you the browser. I showed you the debugger just a little bit. I showed you the inspector already, and maybe I'll show you Monticello too, but let's go ahead and look at the code inspector. So let's get a code browser up here. That's browser over here in the world. This is the other window you spend most of your time in. It's this little browser here. On the first column here, we have packages. So the packages are collections of classes. So for example, let's go down back to kernel, collections abstract, collection sequenceable here. So we have collection sequenceable. And that's going, the second panel now has listed up all of the different kinds of things that are in the package collection sequenceable. These are classes: heap, interval, linked list, ordered collection, sorted collection, and so on. And notice that as I'm clicking on this, the third and fourth column change. The third column are the protocol collections, which means that it's a group of messages, a group of methods that have similar functions that are named in a way to hint at what they actually are for. There might also be a category there called private. There's nothing that enforces privacy in here, so anybody can call any method, but there are tools that sort of lint your code, go through and look to see if you've done anything bad. And if you have called private methods from outside the class, you'll get warnings in that lint tool. So this is an indication that maybe you shouldn't be calling these outside because it's not for you to call out there. If you just want all of them, you select all, that goes all the way down to the list regardless of what thing they're in. Now, the other thing to notice is that we have this stuff down here at the bottom. Let's go to word collection here. So we have instance highlighted right now. It comes up by default like that. That means that all these methods are instance methods, not class methods. If I select class over here, I'm seeing just what I would send to the class. So typically a much smaller, in fact, they're all under the category instance creation here, so not a lot of things going on over here. Of course, all I'm looking at are the things defined in the class itself. This is actually lives within a hierarchy. The ordered collection inherits from someplace else, which inherits from someplace else. And there are ways to get at all that. We can look at the hierarchy. Here's all the hierarchy of everything put together from sequential collection, from order collection upward, and everything that inherits from order collection down below. We can also look at the comment, the class comment. I represent a collection of objects ordered by the collector. Okay. We can also look at the full hierarchy. So this brings us into a hierarchy browser, which is a lot of fun. It's similar, but all the classes now on this left-hand side are restricted to my superclasses and my child classes only. But I can do the same thing in here that I can do in the other browser. It has all the rest of the same features. It just narrows it down to just the hierarchy. But from here then, we can see that from sequenceable collection on the class side, we have these other three methods that we can inherit. We also have collection, which we inherit with, that's how to create them. We all the way down to object. Object has tons of methods. Everything, it's like a junk drawer. Everything goes in object. If you want every object to understand it. And again, we put the instance here. We can see what all the instances are, ordered collections, understand these, and so on. One other view that's also very handy is called the protocol view. In this case, it's all flattened out. So rather than having any notion of a hierarchy in here, we now have all the methods brought down and flattened down to one evaluation. So for example, I would look at evaluating, I would look maybe at futures, I would look maybe at testing, and over here again we can look at each of these methods, but now we also see what class they were inherited from. So lots of different ways to view all this stuff. Really makes it easy to program looking at it from different kinds of views. So over here again, we select the protocol. Over here we select an actual method name. Now, once we select that, we have the code down here, just like I showed you before. Here's the signature, add after with new object and old object. We have a comment in here, typical, but not everywhere. Mostly in code that was older. Most of the stuff in the original Smalltalk 80 image was actually commented, but squeak's been added to by a lot of people since then. So here we have a local variable, and here we have the actual code being executed. Again, you've seen all this syntax, so I won't go into much more detail here. If I want to create my own class in here, which we'll have to do for the exercise, we would go back to what's called a, I forget what it's called. It's called something like a prototype or something. Definition. So if I go here to this particular class, we see that this class, PR delayed persistency, doesn't matter what it does, is a subclass of PR history persistency. So this looks like it's just a definition. Here I have my instance variables. I don't worry about class variable names or pool dictionaries, hardly used anymore at all. Looks like we have 3 instance variables for each of these objects. And there's also categories. The category is also here. Now this looks like it's just a definition, but this is actually a piece of Smalltalk code. You can run this and it would create that class. So we can do the same thing to our own class. So let's say we go, I want a subclass object. I want to call it, say FizzBuzz. And I'm not going to have any instance variables to begin with, so let's get rid of that. And I want to put it under Randal Dojo. Okay? And I say, then I just, notice the orange up over here, that means it's not saved yet. So I hit Command S or Control S on Linux. And now we just created a brand new category at the top, brand new package at the top. We created a class called FizzBuzz. I can go in here and make a comment. I think we comment. Oh, I have to select this up here, sorry. A comment. It kind of gives it away. So let's see. I am the solution to all your problems. Again, not saved, so I save it, okay. Now to create a new message in there, I would go over here. Now, I don't want to make a message on the instance side, I want to make a message on the class side, just so I can just quickly demonstrate this. So again, we have the class side, we've selected that, we can select up here in all, we get a template, and we could have say hello world. And we're just going to answer hello world. Again, notice the syntax coloring is telling me when the syntax isn't correct yet. It actually is completely recompiling the code over and over again until we get to the point where it actually works, and then it tells us right away. Command S to save. Now notice we have say hello world, which is now a method that I can send to a FizzBuzz. Okay, but notice it still says as yet unclassified. That's because it has no idea what class that should be in. So we're just going to rename that demo stuff. Accept. Okay, now it goes in demo stuff. Okay, now it's in the system. So I can go over here and go FizzBuzz, say hello world, print. There we go. That's how fast the code was in. So you're going to spend a lot of your time creating code either directly in the debugger by fixing things that are broken. In fact, it's especially true in test-driven development because your test is going to fail. You're already in the debugger. You can just fix the code right there in the debugger, and that's what you don't have to go to a separate code browser then. But if you're adding new methods, it's easier to come out here to a browser and do that. The browsers are all synchronized, so if I had 5 of them open and I change the code in one, they all tell each other, so the code gets updated in all the windows. It's actually pretty smart about all that. Okay, what else do you need to know about this? You can also do things like figure out who the senders and implementers are. So let's say I'm looking at some code. Let's do something easy down here. Tests, kernel models. Let's pick one over here. Let's say you're looking at this and you're going, okay, I'm trying to understand this code. I don't know what this thing is. I highlight it and I go down, unfortunately, to the second menu. I wish it was on the first menu. Explain. This is my favorite thing that I found back in 1982. It figures out what that is. It is a message selector which defined an object, standard system view, and you can get to that by going to implementers of. So let's undo that, and we'll go to implementers, and I say implementers of is window for model. Right now, I'm looking directly at the code of all the different things to implement that in just a couple of clicks. You know, it's really nice having all the code, very visible, really interactive browser. Nothing works this way. This worked this way in 1980, though, on a 1 megahertz processor. This was all running just fine. How far we haven't come, you know, because we already had this back then. So this is why I still think Smalltalk beats the pants off a lot of things, because it's just this kind of interaction just doesn't exist anywhere else yet. Okay, so also I would say, well, who would send containing window? I can hit senders containing window. Now we get everybody who sends it, and that code is highlighted in each one of those. So if I don't know exactly how a method is used, I can see who sends it. Now, not all of these are sent to that other method that's there, because it depends again on the object types and things like that. At least I can get some examples, particularly if the name is particularly unusual. There's also, what's the inheritance for this? That'll only light up if there's actually some overriding going down. Again, hierarchy, give me the instance variables, class variables. We can do things like instance variables in there and get all the references to them and stuff. One last thing I want to show is over here in source code. Here's the source. I can go down here to pretty print, which will force it to always look, yes, it'll always make it look the same, then it'll force you to be pretty printing. But the one thing I like is we have bytecodes. So I told you everything's a bytecode. There's the bytecodes. So that's the opposite into the bytecode array. Here's the actual bytecode, 70, D1, 1. But this is the code that actually is doing the actual execution. Now you can't type anything in this way, but it's kind of nice to look at it. Actually, you probably could call the compiler class and hand it that. Yeah, anyway, you can do everything. Forgetting it's small time. Okay, let's go back to source, back to the original source. Okay, back to my slides. So the workspace. Packages, we got that. Okay. Source code management tool keeps track of package dependencies. Each source code management repos are storing versions of those packages. Each class belongs to only one package, as I said. So, but the package management system, it allows you to define monkey patching, which means that if for example, in my Randal or my FizzBuzz, I needed to have a method on numbers. I would find the number class, Command F, number. Okay. And actually I need it on integers, so let's put it in integer. And I have this over here, but if I go over here and define a new category that starts with a star and the name of my package, and then anything else that I want, like Randal Dojo override. And if I put methods in there, the packaging system considers those methods to be part of my package, not part of the original integer package. Which means that when I roll out my code back to the repository, it'll also grab all these other independent things, and when it brings it in, it'll patch all these other things all in the right place. But clearly, here's the thing that, that's being, in fact, actually what we're seeing is, okay, files package, the Minicello core package, the Grease core package, all of those are actually monkey patching integer. But let's go ahead and actually do it. This would be kind of cool. So we do it here, those overrides. So we say as my weird thing. Okay. Oh, here, let's look at add 3. Okay. We return self-listed. Okay, let's say I needed that in order to make my code work. Command S. It's now part of my package, but now I can go here and say 7 plus 3. Add 3. See, it even knew that plus 3 was wrong, but watch, it already knows about add 3. It's already in the system. And I run it. There we go. Automatically added 3. So I'm able to monkey patch anywhere in the system. Of course, again, use that with caution. And the important thing is your names probably won't collide with anybody else who has to monkey patch it in similar ways. So that works really nice. Everybody understand the term monkey patch? It's a pretty common thing. You monkey around with other people's code, even though it's not yours. Yeah, right. It's a term that came from the Ruby community, but we've sort of adopted it back in the Perl community as well. Okay, anything else I want to do there? No, let's leave it at that. Put that in there. Backwards slides. We saw the code browser, packages, classes, class instance, method categories, method names. Again, view and edit the selection. Sometimes it comes preloaded with a template. We saw that. Lots of coding available, help available in the menus. The inspector, we saw the simple inspect. It gives you the debug value. You also have the inspect view, which is a hierarchical view. So we could do, for example, let's take 1 to 10 as array. And then, before I hit Command I, which is inspect, and it gives me this sort of a viewer here. But I tend to spend more of my time in a hierarchy. For example, if I was drilled down to each of these, and these were all independent values as well, that'd be kind of hard because now I'd have to go over here and say inspect this now, and that gives me the next level. But there's also the Explorer view. So if in here, if we say explore it, which is a capital I, hard to tell the font there, but it is capital I, or again, Command I on the Mac, we get exactly the same thing. No, Shift. Got the Shift I. There we go. So now we get a nice hierarchical view. So now we can drill down, look at each individual value, and operate on that. So, by the way, if you use self down at the bottom pane here, whatever you currently have selected up here, that is self. So you can execute anything you want there, self plus 3. So taking 2 plus 3 is 5. So you can send in messages right from these explorers. Generally, if there's a little box by itself, that's a workspace. That self means something like that's nearby. So any one of those panes, the debugger pane has it, the browsers can all do it. It's just, it's all universally, like, you can interact with pretty much everything that's in the system all the time. Okay, and what else do I have in my slides? So we saw the Explorer view, I showed you the debugger already. Proceed, cancel, full. The full debugger shows you the stack at the top, as the code pane with the current line highlighted, instance pairs in the lower left-hand corner, and temps and arguments in the lower right-hand corner. And everything's live, editable, resumable. Now there are action buttons to do like traditional debuggers. You can step by step walk through some code if you want, and you can say whether to just stay in the current method or if it's another method called to drill down in, so you can go into or over or around. So that's all available to you. For testing, there's good unit testing, which I'll show you in a second. There are GUI test runners for all that as well. Monticello, as I said before, is the primary source code management for Squeak. It's a distributed SCM. It's sort of like Git or Mercurial or Bazaar, in the sense that you can go off and do independent development, and it maintains a hierarchy of what each package is derived from, so that when it comes back together, it can do a good merge because it has a common base point available to it. And it's also Smalltalk aware. So if one of the things you do is rename a class, it knows that the class is renamed. It does the right thing when it merges it. It's not actually like looking at source code line by line to figure out what to merge. It's doing an actual knowledge merge because it knows the classes, the hierarchies, things like that. So very smart. You can store things just on local disk. or you can also put them up on things like Squeak Source. Squeak Source is like source 4